Alrighty, hi everyone. This is a video for IXL Q1 trigonometric ratios, sine, cosine, and tangent. Let's take a look at our first problem. It says find the sine of angle W. Okay, so first thing I'm going to do is I'm going to grab my tools down here and I am going to circle the reference angle both in the problem and in the picture. So our reference angle is W. Then I'm going to label my hypotenuse, my opposite side, and my adjacent side. The hypotenuse is always across from the 90-degree angle, and I'm going to label that with an H. The opposite side is always across from the reference angle, and I'm going to label that with an O. Notice how I'm labeling the H and the O right next to the side lengths right there. That's going to be really important because these are the numbers that we're going to use to build our ratios here in a moment. And then finally, the adjacent side is right next to the reference angle. So we're going to put an A right there next to 28. All right, they want us to find the sine. We use the mnemonic device, SOHCAHTOA, to remember our ratios. So sine is SO. So that's S-O-H. And those letters stand for sine, opposite, hypotenuse. So that's telling us that the sine is O over H. Okay, so O over H, O is 45. Let's see, and H is 53. And then we need to check to see if we can simplify this fraction. Okay, so to simplify, I'm going to pop open the Desmos calculator. I'm going to put 45 over 53 in. So that'll be 45. You can do divided by 53, or you can use the little fraction tool here. And then we don't want to use the decimal. We want the fraction equivalent, and it's still just 45 over 53. It cannot be simplified. So that is going to be our final answer. Click on the box. You're going to put a fraction in here. So 45 is our numerator, 53 is our denominator, and we are going to go ahead and submit. All right, moving on. Find the sine of angle U. Start by circling the reference angle both in the problem and in the picture, and then start to label your hypotenuse, which is across from the 90-degree angle. Your opposite side, put those H, O's, and A's right next to the numbers. Your opposite side is across from the reference angle, and your adjacent side is right next to the reference angle. Okay, now we are going to write our ratio. Again, we have sine, SOHCAHTOA. Sine is S-O-H. So that tells us that the sine ratio is O over H. And we're going to go look at our picture to build that ratio. O is 8. H is 10. 8/10 definitely can be simplified. You can do that using your mental math facts if you want, or if you just want to be sure, you can do 8 over 10 in the calculator. Click on the little circle and it does simplify to 4/5. So 4/5 and hit submit. Okay, let's keep on going. Find the cosine of R. So let's go ahead and let's circle our reference angle in the problem. Circle it in the picture. Label the hypotenuse, which is across from the 90-degree angle. Label the opposite side, which is across from the reference angle, and label the adjacent side, which is next to the reference angle. Let's go ahead and write our ratio. This is cosine. So SOHCAHTOA, C-A-H, stands for cosine equals adjacent over hypotenuse. Go over to the picture, find our letters, A and H. 20 over 52, that can definitely be simplified. They're both even numbers. 20 over 52, over to our calculator. 20 over 52, click on the circle, 5/13. And hit submit. Okay, next up we have tangent. Circle the reference angle. In the word problem, circle it in the picture. Label the hypotenuse, go to the 90-degree angle and go across from that. Label the opposite side, go to the reference angle and go across, and then the last side is your adjacent side. Write your ratio. Tangent, SOHCAHTOA, tangent is TOA. TOA. TOA means tangent, opposite over adjacent. Go to the picture. Opposite is 30. Adjacent is 16. 30 over 16, click on the circle, 15 over 8. All right, cool. So now we have a problem where we are missing a side. Okay, so notice we have 48, 55, and we're missing this side right here. We are going to use the Pythagorean theorem to find the missing side. When you're missing the hypotenuse, we just use this. So when we're missing the hypotenuse, we're going to do the square root of the one leg squared plus the other leg squared. Okay, and our two legs are 55 and 48. So I'm going to go over to the calculator and we're going to use this format. The square root of the first leg squared plus the second leg squared, that is going to give us this hypotenuse right here. So let's clear it out. We need a big square root. Okay, first leg squared, 55. It doesn't matter the order here. And we want to square it. Click on this button to square it. Plus 48 squared. Equals 73. Okay, for these problems in this lesson, you're going to end up with whole number answers. If you get a decimal answer or an undefined answer, you made some sort of a mistake. Okay, so 73 it is. Let's go back over here and let's label it up. This is 73. Now we can go through and we can mark up the figure like we normally do. Reference angle is I. Circle it in the problem, circle it in the picture. Find our hypotenuse. Write that H right next to the number for that side. Find our opposite side. Find our adjacent side. What's this asking us to find? Cosine. Cosine is C-A-H. Cosine is A over H. A is 48 from the picture, and H is 73. Simplify it in the calculator. 48 over 73 is just 48 over 73. Does not get simplified at all. 48 over 73. Okay, cool. Another one where we're going to use the Pythagorean theorem. This one, it's one of the legs that are missing, so we're going to use a different form of the Pythagorean theorem. We're going to use the same theorem, but just rearranged in a different way. When you're looking for a leg, not a hypotenuse, with a hypotenuse you do the square root of the sum of the legs squared. When you're finding a leg, it's the same thing, but you're going to subtract. Okay, and here order does matter. So you're going to subtract these two numbers squared. Always do the bigger number first. Okay, the bigger number is the hypotenuse. So let's pop over to the calculator here. Let's clear it out. We do need that big square root. And then our larger number is 65. That's the hypotenuse. So we need 65 squared. We're finding a leg, so we're going to subtract. And then the smaller number is 56. And we're going to square that. Okay, so our other leg is just equal to 33. That's nice. We ended up with a nice whole number answer, so we have confidence in that answer. Let me just show you real quick. I'll come back over here. If I had accidentally done the 56 first, so 56 squared minus 65 squared, you get undefined. Okay, so if you have undefined, it means that you need to flip your numbers. The larger number has to be first. You can't end up with a negative under a square root. Okay, so back over to our problem. Let's go ahead and go through our process here. We're going to circle the reference angle in the problem. Circle the reference angle in the picture. Label the hypotenuse, which is across from the 90-degree angle. Label the opposite side, which is across from the reference angle. And label the adjacent side, which is next to the reference angle. What's this asking us for? Tangent. Tangent is TOA, SOHCA, TOA. TOA is T-O-A, and that stands for tangent equals opposite over adjacent. Tangent is O over A. Let's go grab those numbers. O is 56. A is 33. Into the calculator, let's check it. 56 over 33 is just 56 over 33. That does not get simplified, and so that is going to be our answer here. Why is it not typing? There we go. 56 over 33. If I can type that incorrectly, hopefully that's correct. There we go. Okay. I don't think I'm going to do any more. We went over all of the different types of ratios. We did a sine, a cosine, and a tangent. We did a problem where you guys had all three sides. For those, you just have to mark up your figure and write your ratio. We did a problem where the hypotenuse was missing. For that one, you are using your Pythagorean theorem where you are adding the squares of the legs. And we did one where a leg was missing, just like this problem right here. And that is where you're taking the square root of the difference between the hypotenuse squared and the leg squared. So when you're missing a leg, you are subtracting inside of that square root. Then once you have the missing leg, then you're just doing the problem as usual. All right. Good luck, guys. Let me know if you have any questions.